All right, so today we're going to continue on conditionals. Reminder that on Monday there's no lecture or office hours or help hours on Monday because of Labor Day. And also we released Hack 1, the results of Hack 1 this morning. That's how pretty much they're all going to go. That they are graded, or they're due on Monday evening, so the grading is assigned on Tuesdays. We have them graded by Wednesdays, but then course leaders go over them to make sure that everything looks good. And then finally, they are released on Fridays at the latest, usually. All right, good. So remember, we are on Piazza, and we have our YouTube live stream here. Another note is that your Hack 2 is, of course, pushed back a day. So consequently, grading might be pushed back a day, and of next week that it's not due until Tuesday evening. Okay. All right, so we started talking about conditionals in both languages, right? The basic if statements are the same in both languages. The basic else statements are the same in both languages. And if-else statements are mutually exclusive. What that means is that exactly one of these things is going to get executed. So if A is equal to 10, and I have an if statement here, right? If A is equal to 10, then it prints one thing, printf A is 10, right? And if you just leave it like this, of course, the else statement is always optional. And so this is do something or don't do it, right? If you want something like do something or do something else, right? Do A or do B, A is not 10. Right? There we go. Then you can have an else statement. Now notice the syntax that I've used here, or the style of syntax that I've used here. The opening curly bracket is on the same line as the if statement. The closing curly bracket is on the same indentation level as the I in the if statement. And then everything is indented at the same level in both code blocks. Okay? That's the modern convention that I would encourage you to use in both languages. Again, it doesn't really matter as long as you are consistent about that convention that you're following. Okay? All right. Remember that these things are called mutually exclusive because in an if-else statement, either this block gets executed or this block gets executed. It's never the case that both of them get executed. It is never the case that neither of them gets executed. It is one or the other, okay? You can also generalize this, right? You can generalize this to an if-else-if condition if you've got more than 3. And to do that, let's see, let's go with Husker score, right? And I don't know what it's going to be. Who are we playing? North Dakota State or something like that? Say what? North Dakota. There we go. Score, right? And again, I don't know what score theirs is going to be. In fact, as of 2 days ago, nobody even had any lines on them, over-unders. So who knows? Bookmakers are not even letting people or publishing bets yet. All right. So, but if the Husker score is greater than the North Dakota score, then what is the outcome of the game? Huskers win, right? Yay. Otherwise, if that's not the case, is it always the case that Huskers lose? Huskers lose. Right. Or is there a third option? They could tie and then go to overtime, and American football does not allow ties, right? So it's not necessarily the case that they lose, right? That's only if the North Dakota score is greater than the Husker score. Right? Then the Huskers will lose. Right? And then you can, again, with an if-else statement, there's nothing fancy here. There's an if-else, and then this is just another if statement. Right? There's not really an else-if keyword. It's just stringing these things together. Some languages do have an else-if. If you've done any Python, if you've got an if-else, the same keywords. But if you've got an if-else-if, what do you use in Python? Isn't it ELIF, right? ELIF, right? Because they needed a keyword. And well, I don't know why you need a keyword when you can just string these things together. And the else statement here would then be printf tie, right? Overtime, because we do not allow ties. Right? There we go. All right, so let's see this in action. Again, if you've got the lines out there, great. Let's just say 50, huh? And let's say that the black shirts actually do a good job this week and keep it to 17, let's say. All right, GCC demo. got to give something up. Right? There we go. So who wins? Huskers win. Right? Let's change that score. Another quality loss. Right? Huskers lose. Right? Otherwise, if they were the same, then there, tie overtime. Again, mutually exclusive. Exactly one of these three things will execute, and only one of these three things will execute. The first one that evaluates to true is the one that gets executed. So we check this condition here. If that's true, then we do this, and we skip the entire rest of the else if, else if, else if. Right? The first one that actually evaluates to true is the one and only one that gets executed. And again, the else statement is going to be a optional. Right? There we go. Put that in the notes for you. The order is important, right? The first condition that evaluates to true is the one that gets executed. And for that reason, you want the most specific conditions first and the most general conditions last. In fact, the most general condition here is a catch-all. If nothing else, then the else, right? That's what gets executed. That's the default, right? All of them are mutually exclusive. The first one that's true gets executed. Is this? Yeah, this is, okay. I don't know why this is not rendering on my end, but it's rendering on your end, so it looks good. Like before, the else block is optional. It essentially allows you to have a default behavior. And when you're writing these things, you always start out with the most specific conditions, and then you list more general conditions as you go along. Now, we've implicitly been using these numerical comparison operators, right? Strictly less than, strictly greater than, less than or equal to, greater than or equal to, etc. You can also have equality, though. Right? And we've used this one really shortly, but equals equals. And the reason that we use equals equals is because the equal sign already has a meaning, an assignment operator. Take the thing on the right-hand side and put it into the variable on the left-hand side. To negate that, you can go ahead, you don't have that nice, mathematical symbol, not equal, there we go. Something that looks like that on your QWERTY keyboard. So what's the next best thing, or how can we approximate that? We simply put an exclamation point in front of an equal sign to get the not equals. Okay. In fact, the exclamation point is a general negation operator. You can place it in front of any expression to flip true to false and false to true. Right? For example, let's look at this. If I've got the condition A is strictly less than B, right, is true if and only if A has a value strictly less than B, right? What if I did the opposite? What if I negated A is less than B? Give some more room there. It is true if and only if what? Dot, dot, dot. What's the negation of that? Is it strictly greater than? Right? If A has a value strictly greater than B. Is that the only case? Or equal to, right? A value greater than or equal to B. In other words, I could rewrite that as what? A is greater than or equal to B. Which one of those is better? Placing a negation out front and then the inequality, or this thing right here? That thing right there, right? Keep it simple, KISS, right? Keep it simple. That's much better, or you keep it, KISS principle. KISS. Keep it stupid simple, right? Simpler code is better to read, it's easier to maintain, etc. Right? In neither, I'm going to emphasize this greatly, language can you use equals or nor, I should say, not equals for string comparisons. Now you're going to be kind of spoiled if you're coming from a Python background where you can do something like this. Those are dynamically typed languages that understand that stuff. Neither language can you use that. You're not going to get the great results that you expect, right? For example, let's go over here to Java and demonstrate this. string A is equal to, I'm going to create a new string with apple in it. There we go. String B is equal to new string with also apple in it. Right? If A is equal to B, system.out.println, same strings. And I don't need to end the line, right? But I do need to spell system correctly. There we go. Else, not same strings, say. Not same strings. What's going to happen here? Apple and apple are the same string, aren't they? So they should be equal. So should it print out the same strings? Not the same strings. Why? Because equals equals in both languages is actually comparing the memory address of those two things. You'll have a similar failure in C, right? In C, there won't even be a warning. Here, there's not even a warning. It lets you do this, right? Because it wants you to be able to compare, is that object the same thing, thing stored in memory as that thing over there, right? Two references referencing the same memory address. Don't think that you can use that in general, though, okay? Okay. Again, these are comparing memory addresses. You can't do it. Boolean variables. Right? Often, you want a variable to hold the value true or false. These are Boolean variables. Right? Examples would be, say, I don't know, if you're in a loop, eventually we'll get to loops next, done, right? A variable that's just a flag variable that says that you're done with the loop and you can break out of it. Something a little bit more relatable here is student. If somebody is a student, true, they're a student, they get a discount. False, they're not a student, they don't get a discount, right? Or is freshman, they get an even bigger discount because they're freshmen, yay, right? Or they get free football tickets because we cannot have the sellout streak end, right? You're still selling out if you give them away somehow. All right. Well, this is where the two languages diverge a little bit. In C, there are no, I thought there was a question online, but in C, there are no Boolean variables, right? Instead, numbers are used for Booleans, right? True, or I should say false, is 0 by convention. True is any non-zero value, right? 1, of course, is the placeholder that most people use, but that's not it. 42 is also true. 3.5 is true. -10 is true, right? Anything that is non-zero is true, right? And consequently, you usually use an integer for a Boolean, except you can bring in a library to do it. The std bool library, right? And that will give you the constants true, false, and it'll also give you a Boolean declaration. Let me go ahead and show it to you in C over here. So let's go ahead and say that we've got int is student. This is the first version. Now I can't set this to true unless I bring in that library. Instead, what is true? I could set it equal to 42. They are a student, right? But why are you being weird? Why are you using that weird number there? Just go ahead and use the convention of 0 and 1. Right? So I could ask if is student is, say, 1, then they get a discount. Printf, you get a 10% discount. And by the way, can I do that with the regular percent sign? Percent signs are for placeholders. So to get the actual percent sign, what should I do in C? 2 of them, right? Else, printf, full price. There we go. Now this will work. Our student here is going to get that 10% discount, right? But what if I, again, was weird about it and I said 42 is also true, so I'm just going to go ahead and use that. Is this going to give us our discount? Is student equal to 1? No. Full price. I'll put in an end-line character there. Right? So don't use this style of syntax. What you can do is you can simply take that away. It's either true or false, right? It's either 0 or non-zero. And in this case, I'm going to catch all of those values, right? Whether or not it's 0, 1, 2, 42, -5, right? And I'm able to just use this as a Boolean variable. That's the preferred style. Otherwise, as an alternative, let me go ahead and, get rid of this. And let's declare an actual Boolean variable. There's actually not a Boolean variable, but std, what was it again? Bool.h. And that allows you to do something like this. Bool is student. And I can set that to equal to true, or I could set it equal to false. Now, taking a look at that library, the only thing that they're doing here is using defines, preprocessor directives. True ends up being 1. False ends up being 0. Right? So if you are going to use this, absolutely you have to use that syntax there. Right? Because you could get some squirrely weirdo that put together their own std bool version that was completely conformant to whatever standard there is, but instead they did, and I'm not going to be able to do it, but 42. Right? Wow, good job. Yes. Failed to save it. That's not a file I should be editing, right? Good job. All right. I'll go ahead and put this over here in the code so that you have an example. And now let's talk about how C diverges from Java in this case, right? So in Java, you have an actual built-in it's a standard value. It is not something where you have to bring in a library for it, but a Boolean, and they could afford the whole word instead of just bool, right? Variable type. And use it, right? Use it. You can use the keywords true and false. So let me go ahead and take this code that I was working on here and bring it over to Java. How do I have to change this? We don't have bools, we have booleans, right? And of course, I just have to change system.out.printf to system.out.printf. Exact same behavior as before. I'm not sure about that percent though. Okay, it still works. Cool. So if you're using the library, very little to translate back and forth. The only difference would be bool versus boolean. Okay. Use the library, don't use it, whatever you want. Understand, though, that there are going to be libraries and other things out there, other pieces of code that don't use that particular library. And so you do have to remember that there's this convention. Any non-zero value is true. Only 0 is false. 0.0 is also false, but that's 0. Right. Okay. All right. Questions? No? All right, then we can make more complex stuff using logical operators. You can combine statements to form complex statements, more complex statements. You can use the connectives, the logical and the logical or. And those are not code I did not typeset those as actual code, right? Monotype font, because neither language supports the actual words and or. Again, if you're coming from a Python background, what is and or in Python? The words and or. And it's all lowercase, I believe, right? Oh, no Pythoners? I thought there were. It's and or, right? All lowercase? Okay. Help me out, because I do have to use Python in my next class, and then I have to refresh my memory every single time I go in, because how do we do it again? All right. The logical and operator is true if and only if both its operands, the things that it operates on, are true. Right? The syntax in both languages is going to be ampersand, ampersand. It is not a single ampersand. That has a different meaning in both languages. it means a bitwise AND operation. You want 2 ampersands, don't forget it, okay? Here's an example, right? We can have, say, A is greater than B and A is equal to 10 or something. And I'll put those in parentheses there, just to offset them. The parentheses in this particular case are not absolutely necessary because of order of operations, but I never remember the order of operations beyond PEMDAS. So I'm not going to commit that to memory. I'm not going to go to the damn book every single time I want to and look it up and say, all right, which one was this again? Instead, I'm just going to put parentheses because I'm giving it actual meaning, right? And it's also a lot more readable. Okay. So when is this true? It's only true if A is strictly greater than B and that A has an exact value of 10. If A is 5 and B is 2, right? The first one is going to be true, but the second one is going to be false, right? In which case makes the entire expression false. If A is 10, but B is 20, right? B is greater than A, and so the first one is false. It could be that they're both false, right? So it is only false when, it is false when, I should say, the first is false, or the second is false, or both are false, right? Good on and, right? So the logical OR operator is true if either its operands is true, or both. And the syntax here is pipe, pipe, vertical bar, 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 or Sheffer strokes, or whatever, right? The absolute value things, right? Whatever you want to call those things, right? And the example here would be, suppose that A is greater than B, or A is equal to 10. Right? Now, again, it's true, it's only false when both of its operands are false. So it's not like the colloquial OR where you've got, where you say you could have cake or ice cream, right? And the implication there is that you can have one or the other, but not both. That would be kind of like an exclusive OR. Not exactly though, because an exclusive OR, it would not be an option to have neither, right? I don't want to eat either one of those things. No, you have to have one or the other. You have to have it, right? That would be an exclusive OR, okay? And we're not going to get into an exclusive OR here or minute little bit twiddling or anything like that. Here's a nice fact that we won't get into in depth, but when you have a negation and you distribute that negation, right? In algebra, what happens? Let's go ahead and look at this from an algebraic point of view. I'll go into math mode here, right? So if I have A plus B, right? And then I negate that entire thing, what is that equal to? Negative A minus B, right? I distribute that negation over an addition. Likewise, you can distribute a negation over logical operators. That's called De Morgan's law. What happens to that and, though? It flips to an or, and an or flips back to an and. Right? So they're complements of each other. Again, we're not going to get into it too deeply, but you should be aware of that fact because you could probably make some of your statements simpler. Given these two statements, however, which one is easier to read? It is not the fact that A and B, or not A or not B. I don't know. All right. I kind of like the first one better because it allows me to think about the actual statement A and B, and then all I have to do is after I've thought about that statement, flip it around. Right? It all really depends on what A and B are. They're going to be expressions or Boolean variables or something. But if you can rewrite your logical statement to a more readable, compact, understandable statement, then you generally do that. You'll get into this, especially if computer engineering folks get into circuit design, right? You want to minimize the circuit as much as possible. It's all just logic gates. If you can use De Morgan's law and distribution and stuff like that to simplify a circuit from, say, 50 gates down to 10 gates, right, you do that. Why? Less power, less complexity, less faster, because now it doesn't have to go through 50 different gates. It only has to go through 10, right? And you'll get into that later on, circuit minimization and stuff, right? Here's an example from before. If they're a student and they're a freshman, but they're not, right, is equivalent to they're not a student or they are not a freshman. Now which one is more readable? Basically, I'm excluding a group here, right? There probably isn't such thing as somebody who's not a student but is a freshman, right? The freshman implies that they're a student. But the first one is probably way more readable, right? Because all it says is, when I boil it down, is I'm excluding freshmen, right? Not a freshman, not a freshman student. The second one is, that's a much more of a mouthful there, right? Okay. Questions on this so far? No? Then let's talk about some pitfalls. These pitfalls are only germane or relevant to C, right? Consider the following block of code. What's it going to print? What's my intent on that if statement? I'm looking to see if A is between 0 and 10 inclusive on both ends, right? Well, A is equal to 5, so it should print out foo, right? Okay, let's try it. Come over here. There we go. Give myself some more room there. GCC A dot out. Ooh, it works. All right, well, let's try some corner cases here. What if it's 0? Foo, excellent. What if it's at the other end, 10? Excellent, so works. Ship it. Right. Commit it to my GitHub repo, I'm done. Right. Is that all the testing I should consider? I only considered positive tests. Right. What other tests should I consider here? No?
Tests outside the 0 to 10 range.
Okay, so negative 10. What should it print? Fail. That's the intent, at least. But it doesn't. It prints foo. What if I went 100? You know, on the other side of that range. Oops. There we go. It also it prints foo instead of the intended fail. What's the problem here? I've got two inequalities here that are read left to right when it actually gets coded. So let's go ahead and read the first one. Is A less than or equal, or is 0 less than or equal to A? Yeah. So is this true or false? True. What was true again internally? Probably 1. Is 1 less than or equal to 10? Yep. What if this were negative 10? Now, is 0 less than or equal to negative 10? Nope. False. Is 0 less than or equal to 10? True, right? So what ends up happening? Prints foo. You can't do this, right? I wonder what happens in Java. Let's do it like this, because I want to keep this, so I can cut, paste, cut, paste. What happens in Java? What's it complaining about? The operator is undefined for the arguments to type Boolean and then an integer, right? Because when this gets evaluated, it's true or false. Can you compare true with an actual number? Nope. Those numerical comparison operators are only for numbers. And so Java refuses to even compile this. But because over here in C, we don't actually have any Booleans, it's just syntactic sugar brought in by this library over here. we have this issue. It will compile, it'll run. In fact, it didn't even complain, did it? Here's a trick that we'll look at later on. I want you to complain about the stupid things that I do, right? That you can catch. I'm talking to the compiler now, right? As if the compiler cares. I'm putting in the wall flag. The wall flag stands for warnings, all of them. Hey, it's asking warning. Are you sure about this? Right? The comparison of constant 10 with a Boolean expression is always true, right? Comparisons like this do not have their mathematical meaning. Are you sure you know what you're doing here? Right? And now it's warning me about this because I turned on those warnings. So Java, not an issue because it won't even compile. It'll compile, it'll run, it'll not give you what you want in C. Right? The correct way of doing this is, of course, using the logical AND operator here. If it's less, if A is greater than or equal to 0, and A is less than or equal to 10. Now remember, stylistically up here, we said don't do something like that, right? That you shouldn't do something like this because it's that's the weird way of reading it. Here's an exception to that guideline, right? This looks a lot better if you're trying to look for a range, right? So this is more readable. All right. Consider the following piece of code. Int A is equal to 5. If A is equal to 10, do something. What's the problem? Well, let's come over here and find out. There we go. Print that. There we go. Oops. Okay. No, ignore that. Again, the wall flag is warning me that I'm doing something stupid. You tell me. You're smarter than a compiler. What do you see? Yeah, it's not a comparison. What is that thing? A single equal sign. It's an assignment operator. So let's walk through this before I actually run it. If A, it's not no condition here. I'm going to put the value 10 into A, right? And it ends up getting evaluated as 10. Is 10 true or false? True. So it ends up printing foo, despite the fact that that's not what I meant to write. Right? It ends up printing out foo. And the problem here is that I was using an assignment operator instead of the proper equals equals. And if I put that in there, now of course it's going to work correctly, right? It doesn't fail anymore, it passes. Okay. So the above will compile and run, but it will not give you what you want. Be careful. I wonder what happens. Ignore that. You didn't read that. What happens in, say, Java? There we go. So let's get rid of that equals equals. And you see Java's a little bit smarter about this, right? It says you can't do that. If you're going to have a condition, that condition has to be a Boolean, a true or false. It can be an expression, it can be a Boolean variable, but it can't be this assignment operator because we have true and false in Java. We don't have these numerical placeholders where 0 is false and anything else is true. So it's not going to compile. We don't have that issue. Great. All right. There we go. So it does not compile. Last pitfall here. And you tell me what's wrong here. If A is equal to 10, print A is equal to 10. Okay. I'm going to set A is equal to 5. Compile and run. What should it print? Should it print that A is equal to 10? I set it equal to what? 5, but it says that it's 10. Why? Semicolon, right? Let's move that down there. If A is equal to 10, do what? Nothing, right? And then move on with the rest of the program. Printing A is 10 down here. It's not bound to that if statement. So let me go ahead and bring this up here and show you that, again, if you use the WAL flag here, it'll warn you about that. Just a warning, right? It's still compilable. I wonder what happens in Java. There. Oops. Nope, undo that. System.out. There we go. System.out.printf. There we go. It compiles. It'll run. It'll give you bad results. A is 10. Why? Well, you didn't do anything wrong. You didn't do anything illegal here. You said if A is equal to 10, do nothing. So it does nothing. Right? And then it moves on with the rest of the program. Again, computers are dumb. They only do exactly what you tell them to do. Right? Now, you saw that trick there that if you try to format this code, what will the formatter do? It'll recognize that you said do nothing. And it'll end up putting that semicolon on the next line. And now you know, oh, yep, that's wrong. Right? So, be careful. Those are just some of the common pitfalls that we see. Right? It's okay in both languages. The tool that I was using is called a linter. Right? What is lint? Yeah, little bits of cotton and dust on your clothes. Does that mean that when you take it out of the dryer, right, you've got lint on it? It doesn't mean it's dirty, right? It just means that it's got little bits of lint, of fabric that have fallen off of other clothes and then collected. They're still clean clothes. It's still code that will compile and run. It's just that, wait a second, there's lint on that code. There might be something wrong with that. That might lead to a bug. Let's go ahead and clean that lint up. So how do you clean lint up? You can't put it back in the washer and wash it again because the washing process is what put lint on it in the first place. So what do you use? Lint roller, right? A little what is it? Sticky thing that will then pick it all up, and then now it's clean and it's lint free. That's what a linter does, right? A linter will go through your code and not find bugs or syntax errors or anything like that, but look at things and say, that doesn't look quite right, right? It'll say lint is not necessarily dirt. It's not necessarily a syntax errors or obvious bugs or anything like that. It's just stuff that we don't want in there. Probably we don't want in there. Now, if you run a linter and you say, okay, the linter says, take a look at that thing because I don't think that looks right, and you look at it and go, no, that's right. I had to do that because blah, blah, blah. Then so be it. But at least you ran the linter and at least it warned you about it, right? A linter is basically what's called a static analysis tool. A static analyzer will look at your code before it gets compiled for potential problems and then warn you about those potential problems, right? It looks at suspicious looking code. So from now on, whenever you're doing C, you can enable your linter by simply using the WAL flag. Tell me about all the warnings that you know about, right? The common issues that you find in C code. What about a linter over here in, say, Eclipse, Java? It's already built in. You see what happened there? There's this little, it's hard to see, but it's yellow down here. Yellow or orange, I don't know. Gold, maybe? So it's between yellow and orange. But anyway, it highlights over here. The value of the local variable is not used. That's a warning, right? Try to clean up all of your warnings, right? If you declared a variable, set it, but you never used it, why did you do that, right? That's cruft. That's lint. Get rid of it, right? It shouldn't be there. Run your lint brush or lint roller over your clothes, right? I don't have any clothes fancy enough to justify a lint roller. All right. Any questions so far? No? All right. One other thing that you should know about is short-circuiting. Right? So we don't have any EE folks in here. many of my other classes I do. But you know what a short circuit is too, right? So if you've got a circuit, right? You've got circuitry. You've got from a power source here, and then you go to a light bulb. Then you go to a light bulb. There we go, and it's nice and bright. And then you go back over there. You've got a circuit. Why is it called a circuit? Because it's circular, right? Energy, current will flow through this one way, and on its way, it's converted into light and heat, right? What happens when you short circuit something? When you cut across these wires here, electricity, like water and like most of nature, follows the path of least resistance. So what's going to happen here if I put my finger across this this light source right here? It's going to go through me because that's the shorter route, right? Versus this light over here having to travel all around and light up this light. That's a short circuit. I've shorted it out, right? I've shortened the circuit, right, into a smaller circuit. What does that mean as far as code goes, right? Consider the following, A and B, right? So, if A is false, does it matter what value B has? Remember, it's a logical and. They have to both be true in order for the whole thing to be true. The answer is no. Regardless of whether or not, whether B is true or false, the entire expression is false. Thus, the evaluation of the expression is short-circuited and B is never examined. Now, this might not seem like such a big deal until you get to more complex code where B maybe is not a variable. Maybe it's an expression, in which case that expression is not even evaluated. Maybe it's a function call, in which case that function is never actually even called. Right? That's very bad style anyway. You shouldn't rely on short-circuiting like that. But it is common to use things like, say, common idiomatic check for null. For example, if A is not null and A is equal to 10. There we go. So we'll get into nullity eventually later on. Let me go to the next line there. There we go. It would be dangerous. A is, here, I'll dereference it just to make sure. Don't worry about that. Just get the idea here. Right? If you were to evaluate A and ask, does its value equal 10, and it happened to be null, you'd end up getting one of those, remember, segmentation faults, right? Where you're trying to access memory that doesn't belong to you. But this, along with short-circuiting, ensures that I don't have that. If it's null, right, then then this is false, and we never end up evaluating the second part. And I'm calling that an idiomatic check for null because you'll find that all over the place. What is an idiom? A phrase that it's a non-literal phrase, right? It's a metaphorical phrase. Give me an example. There's always one quintessential example. Exactly, that's the one that we always go for. It's raining cats and dogs, right? It doesn't literally drop cats and dogs out of the sky. It means that it's raining hard, right? Every language has idioms, including programming languages. Now, in English or other natural languages, you can't translate idioms. If I translated "it's raining cats and dogs" into Spanish, what the hell are you talking about, right? It all depends on your culture and the context in which you're speaking. If you try to take an idiom from another language and translate it into English, nobody's going to understand, right? Does anybody have any non-English idioms? No? I'll give you an example then. Asa meshimae. So that's Japanese for before breakfast. What does that mean? Before breakfast. Now, if I just translated it, we don't understand, right? But if I transliterated it, right, I translated it into the equivalent idiom in English, I'd say it's a piece of cake. It's easy, right? And now it kind of makes sense because, oh, well, you could do something like that before you even have your breakfast, right? Before you had your morning coffee or something. And that's the meaning. It's an idiomatic meaning. Code also has idioms and idiomatic ways of doing things. Again, if you're coming from a Python background, there's always the Pythonic way of doing things, right? You could write a traditional while loop or a traditional for loop or something like that in Python, but that's not the Pythonic way. You should use list comprehensions because that's the idiom in Python. Right? We'll pick up more idioms as we go along, but short circuiting is also, in a sense, an idiom because everybody relies on it now because they write code like this, right? It's not necessary. Think back 50 years ago, right? Why did they put this in there? Right? Well, because if you could save CPU clock cycles by not having to evaluate another expression, you did it. When you measure CPU clock cycles in tenths of seconds, right, and you can cut out half of them, right? Wow, that's a huge speed up. Instead of taking 10 seconds to compute the square root of 5, right, it only took 5 seconds, right? So 50 years ago, that mattered. It doesn't matter today, but we still have these idioms because people see them as familiar and people have grown to expect them. And if they're not in a language, then you're going against expectation and people coming from different languages will not understand it. So that's why we like these idioms. What about the equivalent? Consider that we've got A or B. There. This is where we'll end here today. If A is true, does it matter what the value of B is? Nope. No. The entire expression evaluates to true. And so B is unevaluated. Right? Again, it short circuits the OR condition there. Okay. Questions? Yeah.
So if you're using an if statement to decide whether or not A is equal to 10, you always have to have the A is not equal to null.
Yeah, if you're doing a null check there, that's why the nulls come first because it's exploiting the null pointer check.
Okay.
Right? Both languages here. Let's go ahead and go. We've got a couple minutes here. Integer A is equal to null. Right now, here I'm using the null in Java, which is all lowercase null, right? And if A is equal to 10, then we print it out. What's going to happen here? Oh, well, here, let's get rid of this. I don't want that mistake. Uh-oh, red text. What am I getting? Null pointer exception. Why? Because you tried to examine A to see if its contents were equal to 10, but it's null. It doesn't exist. Right? It's a void. Right? But if I had put in a check, if A is not equal to null, null, and A is equal to 10, else, system.out.println, nope, I don't know what I want to print there. Must be something about the keys. I always get that wrong, ME. I don't know why. Anyway. There we go. So obviously it's going to warn me about this because I never actually set A, so this is dead code. Ignore the warning here, and you'll see that it's much safer now, right? I'm protecting against it by making sure that this is never evaluated based on this first one using short circuiting. Both languages, idioms, everywhere. Every language will have something like this, right? In fact, it's just an idiom, so you can translate it to Python, right? Python, we don't have null. What do we have? How many Pythoners do we have? One? Okay, you got a good couple, right? We don't have null in Python, do we? Nope, we have none, right? We have, and it's capital N, none, or none type, right? Ignore that, that's Python. Right, there we go. Okay? All right, have a good extended weekend, and I'll see you on Wednesday, I guess, next.